Okay, we're going to find out if this converges or diverges, so we could use the limit comparison test. With the limit comparison test, we first need to find out what is actually a similar series to which we can compare this. So a pretty similar series would be one in which we remove all the nonsense there and just reduce it to the essentials. So the essentials would look like that. And then you could further make it even more essentialized by noticing that this is the same as n to the 1/2 minus 1, because this is to the power of 1, so this is n to the power of negative 1/2, which is the same thing as 1 over the square root of n. So that's what we have here. 1 over the square root of n is what we're going to compare it to. So this is the limit comparison test. Limit as n approaches infinity, we have b sub n, and we have a sub n. And so in the case when this limit yields something which is not 0 and not infinity, then whatever happens to b sub n also happens to a sub n. So if b sub n converges, a sub n converges. If b sub n diverges, a sub n diverges. So what's going to happen to this one? Well, it's a p-series. A p-series is of this form. If p is greater than 1, then let's reason it out, because maybe you're not going to remember in a test. So what would happen? So say we had like 500 here or something. If we had 500 for a p-series, what would happen to the denominator? The denominator would get very large. So the term as a whole would get very small. Very small indicates convergence. Very small stuff intuitively indicates convergence. In our case, we have p equals 1/2. P equals 1/2. So 1/2 is smaller than 1. It is smaller than 1. So for our p series, we have n to the 1/2. This is p. So this is the opposite of that. It's going to diverge. This is going to diverge. So we know that this diverges. This diverges. And so therefore we hope that once we take the limit as n approaches infinity of this thing, it doesn't yield 0 or infinity, then we can assume that this one also diverges. Or we have proven that it also diverges. Okay, so, and let's do n equals 1 to infinity. So now let's do this. Let's do this division. A sub n would be square root of n plus 1 over 2 plus n. B sub n would be 1 over the square root of n. We multiply by the reciprocal when we divide. So this is the limit as n approaches infinity of square root of n times the square root of n plus 1 over 2 plus n, because that's 1. And we're multiplying by the reciprocal. So you should remember that we don't want 0 or infinity. So I'm going to get more space here. What happens when we multiply this into that? Well, we have a square root. We can bring the square root. We can bring the term from here inside of the square root. The square root gives it access to the inside. So we would have square root of n times n plus 1 times n, like that. This is n squared, and this is n. And in the denominator, we have 2 plus n. This is the limit as n approaches infinity. Okay, now what do we have? Well, we can look at what is the greatest power here, and then divide by that, because that's what we tend to do when we have this, right? So we can divide by n, because we have n here. You square root the squared, that would give you n, and this is n. So let's divide everything by n. Limit as n approaches infinity, and we have square root of n squared plus n over n, 2 plus n over n. So the way to divide this, to bring that in, is by squaring this, because squaring it and bringing it into the square root. because squared and square rooted is the same thing as just being to the power of 1 in the way that that is. So we would do that, limit as n approaches infinity, and then we would have the square root of n squared plus n over n squared. And here we have 2 plus n. Well, we could divide it to each one. So this would give 2 over n plus 1. Now for this one, we can also, since we're doing addition in the numerator, just divide by n squared each term. On this side you would get 1. On this side you would get 1 over n. 1 and 1 over n. 1 plus 1 over n. Now we can plug in our infinity. If we plug in infinity into that, we would get 0, because we have infinity in a denominator. This goes to 0. This goes to 0. Infinity in the denominator, which would give you 0. Infinity in the denominator, which would give you 0. And over here also 0. So you have the square root of 1 over 1, which is just 1, because the square root of 1 is 1. So we have this go to 1. And this is not equal. This is not equal to 0 and not equal to infinity. So it is the case that whatever happens to this region also happens to this one. So since that diverges, this one diverges.